Hello guys, this is Dave and I am back with an awesome video on circular motion. Okay, so let's start. So you see, circular motion, everyone knows the object travels in a circle, and for example, object is here. This is P and this is O. So when it is going anti-clockwise, velocity will be like this. At this point Q, velocity will be like this, R like this, and S like this. So you see, this velocity at every point is tangent to the circle. Okay, so first I will prove why it is tangent, because this is very important. Okay, so let's start. For example, this is a circle. Okay, and this is the point P. At any point, say Q, which has coordinates x and y, the particle makes an angle theta, say, with the center. Okay, assume anywhere, velocity can be anywhere. I am not pointing out specifically. I'll prove it is tangent. Okay, it can have any angle with this radius vector. Okay, r. So according to this, Q satisfies the circle equation. Okay, x square plus y square would be equal to r square. This is satisfied by Q. Okay, obviously the components of velocity will always be parallel to x and y. So this is Vx, okay, and this is Vy. I have assumed this as x-axis and I have assumed this as y-axis. So you can see these are parallel to x and y-axis respectively, as they always are. Okay, there is no doubting that. So now I differentiate this equation first. 2x dx. I hope everyone knows differentiation, or you can view my previous lectures. I have discussed differentiation in great detail. Okay, this is a must for everyone. 2y dy, this would be equal to 0 because r is constant. Differentiation of constant is always 0. 2 gets cancelled out. Minus x over y would be equal to dy by dx. Okay, and you see, dy by dx can also be written like this: dy by dt by dx by dt. There's no harm in introducing a denominator of dt. Okay, so you see, dy by dt, as all we know, is velocity in the y direction of the particle. Dx by dt is the velocity in the x direction of the particle. This is equal to minus x over y. Okay, so first of all, I want to point out that if this angle is theta and the coordinates are x and y, this means this is y and this is x, right? So minus x over y, what does that mean? That means since tan theta is y over x, this means this would be equal to minus cot of theta. Okay, now since Vx is in the negative direction, this sign can be taken over here. Okay, so this means Vx is in the negative direction. Okay, when we take modulus, for example, Vy over Vx, the mod, we have this cot theta. The minus sign vanishes. Okay, now this was the original circle, this was the velocity v, and this was the velocity's components. You see, speciality of vector is this: this component can be projected here also. Okay, because if lengths are equal, then vector is equal. Okay, drawn anywhere and in the same direction. So these two are equal. Now you see, I had already proved that Vy over Vx would be equal to minus cot theta, and we omit this negative sign because of negative direction of x. Okay, we take the modulus here. So you see, what this angle must be, because Vx by Vy would be equal to tan theta over here, right? This means this angle must be theta. Okay, because tan theta here is Vx over Vy. If we eliminate the directions also, we take the modulus Vx over Vy, this would be tan theta. And if Vx's direction is taken into account, then Vx would turn negative, so this would be equal to minus tan theta. Okay, this is the modulus. So this means that if this is theta, now this is theta, I have proved. Okay, so now this is the center O, this is P, and this is Q, and this was theta. Okay, since Vx is parallel to x-axis, as I told you, that means this angle must also be theta, right? So, and also, you know, Vy must be perpendicular to Vx, because V is split into two components, na, Vy and Vx, and which are perpendicular to each other, because V would be equal to Vy square plus Vx square, right? Due to their perpendicularity. And here we can also see, so this means if this whole angle is 90, this is theta, then this means this must be 90 minus theta, right? And this is theta, that means the whole angle OQR is 90. Okay, the angle whole OQR, this is 90. Now I have proved it. This is V. This means V is perpendicular to R, and hence V is tangential to the circle. Now what does tangent mean? Tangent means the momentum of a particle traveling in a circle is along the tangent. So if you know, if a particle is attached to a string, say, and the string is being whirled around, okay, and at any point Q the string breaks, for example, it breaks, then the particle would fly off in the tangential direction rather than going around circle. Okay, because the velocity is in the tangent direction and the momentum is also along the tangent due to velocity being along the tangent. Okay, so circle, now in circular motion we also have to calculate acceleration. Okay, so first I am going to show you how to calculate acceleration. I am assuming the velocity is constant. Okay, the magnitude of it is, of course. Now let us take a velocity v over here. This is a point P, this is O, and say velocity is Q. Okay, so velocity say is V over Q, and it makes an angle theta with OP. Okay, so we have to find out the acceleration. Now how do we do that? You see, acceleration is the change in velocity per unit time taken. Okay, so change in velocity means V at P, this was the initial velocity, and V at Q, this is the final minus initial by time taken for the particle to travel from P to Q. Okay, this would be the acceleration. Now we can see here the velocity at Q can be divided into two components as earlier thought of. This was Vy and this is Vx. Obviously I had proved that the angle between V and Vy was theta earlier, because here we can transplant Vx and this would be theta. So Vy would be equal to V sine theta j. Obviously this is the j direction, this is the I direction, and Vx would be equal to minus V. Oh, I'm sorry. I'm really sorry. This actually was cos, because this is theta, yeah. And Vx would be equal to minus V sine theta I, right? So this is not sine theta, this is cos theta. Now Vy equal to V cos theta j and Vx equal to minus V sine theta I. Okay. So, and here at P, this is the velocity is at Q. Okay. But here at P, there is only one velocity Vj. Okay. Because being tangent and starting from P, which is horizontally located on x axis, the velocity of x component will be 0. Okay. No Vi. Okay. So, acceleration would be equal to Vq minus Vp over time taken, right? What was Vq? Vq was minus V sine theta I plus V cos theta j minus Vj divided by delta t. Okay. This would be equal to minus V sine theta I plus V cos theta minus 1 j divided by delta t. Now this is acceleration. Okay, this is the vectorial acceleration. We have not taken the magnitude right now. Now we are going to take the magnitude. So A magnitude will be equal to V sine theta the whole square plus V cos theta minus 1 the whole square root of divided by delta t. Okay. So the acceleration would be, this would be equal to V sine theta square plus V square cos square theta plus V square minus 2 V square cos theta, right, by delta t, and the root of this. Delta t is not under the root. I am telling you, it is outside the root. Only the numerator is under the root. Okay. Now this becomes V square. We can take V square outside, it becomes V. Sine square theta plus cos square theta will be 1. V square is outside, so 1 plus 1 will be equal to 2. 2 into 1 minus cos theta divided by delta t. Okay. Now, mod A equal to 2, right, 2 into 1 minus cos theta the root V by delta t. Mod A would be equal to V root 2 dot 2 sine square theta by 2 by delta t. Mod A is equal to, this would be 4, this comes out 2 sine theta by 2 V by delta t. Okay. 1 minus cos theta is 2 sine square theta by 2, and those of you who don't know it, really it is disgusting. I think you should know this. You really should know this, otherwise you should not give the exam. Okay. Now, this would be equal to 2v sine theta by 2 by delta t. Now, what is delta t? This was P, this was Q. For a very small angle theta, the arc PQ, standard notation, we write this as differential distance, and this would be become d theta, right? So by standard notation, if this is very small angle d theta and this PQ is ds, then ds equal to r d theta, where r is the radius of circle. Okay. So s would be equal to r theta for a small angle. This for very small, this for small. So, okay. Now, what would be delta t? Delta t would be equal to s upon v. This would be equal to r theta by v, right? Delta t would be equal to distance traveled upon velocity, right? So this would be equal to r theta by v. Now we substitute this. We get 2v sine theta by 2 by r theta, and v goes up, v square, right? So A would be equal to v square by r, we take this as common, okay. V square by r, we are taking this as common, and now 2 can go down there. So sine theta by 2 by theta by 2, because 2 was originally up here, we can also take it this as denominator of theta. It can always go up. So this is the same expression, okay. So we arrive at expression v square by r sine theta by 2 by theta by 2. So you see, for a very small angle theta, let's say theta by 2, for example x, okay. So v square by r sine x by x, right? And for very small theta approaching 0, let's say, because changes in velocities are very small, you see, over a very small distance velocity is changing, because it is continuously a tangent. It is continuously following a tangent along the circle. So at minuscule points, velocity is changing. For example, here it is this, here it is like this, here it will be like this, like this. So minuscule point, the velocity is changing. This means we have to take a very small angle. So we can take theta reaches 0, okay. This means if theta is reaching 0, from this equation x also reaches 0. So a would be actually equal to v square by r limit x reaching 0 sine x by x, right? And obviously you should know limit, because it is very difficult without limit. तो सीखो limit, ठीक है. मैथ्स तो यहाँ पढ़ा नहीं रहा मैं. v square by r, this would be the modulus of acceleration, okay. So we got the modulus of acceleration as v square by r, because sin x by x would be 1 when x reaches 0. Also by L'Hospital's rule, we can differentiate the numerator and denominator. By differentiating numerator, we get cos x, denominator we get 1. Now we put limit x reaching 0, cos 0 would be equal to 1, okay. So this expression limit x reaching 0 sin x by x, this is 1, and this is v square by r. We get the magnitude of acceleration as v square by r, okay. Now we got the magnitude of acceleration, okay. And you see, we can also find the direction of acceleration. For example, this was the velocity up here, this is the velocity up here, okay. Now we have to find the direction of acceleration. This means the component of this, and we had originally the direction of acceleration like this, minus v sine theta, this was I because angle theta was like this, yeah, plus v into cos theta minus 1j, right? And this is the direction of acceleration by delta t. This is the direction of acceleration. And if we calculate this as for a very small interval we have to take, okay. This means, what does this mean? This means theta reaches 0, okay, because theta here is not very small, alright. If theta reaches 0, we can see that, because when theta reaches 0, this means alright, when theta reaches 0, this means the point reduces to this point P, okay, because theta reaches 0, this will be this point. Now theta reaches 0, sin theta reaches theta. From basic trigonometry, which I am not going to teach here, okay, when theta reaches 0, sin theta reaches theta and cos theta reaches 1. Everyone knows, and if they don't know, please get to know from somewhere, because this is very important. Now we apply this in this equation, because this is the vector A. This is not the magnitude, this is the vector, okay. The proper vector I have taken. Now we apply this, so we see cos theta when reaches 1, this term ends, because 1 minus 1 is 0. Only this remains, and this remains like this, okay. A would be equal to minus v by delta t sin theta is theta I. This means when theta is very small, the acceleration is pointing towards the center. You see, acceleration is pointing towards the center because this is to रहने दो, ये constant है. This has no meaning because direction we are concerned only with direction. Okay, this has no meaning whether it's a variable or constant. This is minus I. So a, when theta reaches extremely 0, is alpha I. Alpha is this expression. So this means a is minus I. Theta reaches 0, obviously will be OP, reaching OP. So a is pointing towards the center. So acceleration in a circular motion points towards center. Okay. So A points towards O. And magnitude of A will be equal to V square by R. So magnitude of A is V square by R pointing towards O. Alright. So now I have taken the acceleration. Okay, this acceleration is called centripetal acceleration. Okay, and so we have the centripetal acceleration even when velocity is constant. You see, the magnitude of velocity is constant, only the vector is changing. Acceleration is there because of change in vector, not because of change in magnitude. Had there been change in magnitude, there would have also been a tangential action, which is not now here because 8 tau is 0 because tangential acceleration is dv by dt, right? If we take the modulus, then this would be 0 because velocity is constant. The magnitude of it obviously is constant. Here it is v, here it is v, here it is v, here it is v. Only the direction is changing. Alright. So in this case where velocity only is constant in magnitude, we have a centripetal acceleration called v square by r. Okay. Magnitude of this is v square by r. Alright. And tangential acceleration is 0. We have to remember this. It's very important. Now, so you see, if there are both accelerations, say centripetal and tangential, we have this would be a tau and this would be a r. Assume. So the total acceleration would be ar square plus a tau square, the whole root. Now acceleration total would not be directed towards the center but somewhere here. Okay, this is a. So this would have been a equal to v square over r the whole square plus dv over dt the whole square. Okay. This would have been the acceleration then. Now I will tell you a much more simpler method for the standard methods done in every book. I think you should know this method. Say assume this is a point P, this is O. Okay, so OP, this is the radius vector and it makes an angle theta. Okay, with OQ. This is x-axis, this is y-axis. Now now you see R vector, this is the vector R. Okay, and if we extend this becomes the unit vector R. Okay, and now we see we can take the components of R. Okay, because this point x comma y, we obviously know that x would be equal to r cos theta, y would be equal to r sin theta. But if we write r, we have xi plus yj, right? So we can take this as r equal to r cos theta I plus r sin theta j. This we have assumed for our own convenience. Okay. Now this x-axis is the direction along unit vector I and y-axis is the direction along unit vector j. Alright. So now r, we have r cos theta I plus r sin theta j. Okay. Theta is also changing. Okay. So we have to calculate the velocity v. We have dr over dt. This is the velocity in standard differential terms for any radius vector. Since this is the original radius, this must be constant. So this means this would be equal to r minus sin theta d theta by dt, as theta is varying, I already told you, this I, plus r cos theta d theta by dt j. The one who doesn't know differentiation should learn it and watch my previous videos. Okay. V equal to dr by dt would be equal to, now we know that this d theta by dt, okay, from basic circular motion, you know that when theta changes according to time, then v equal to this is the differential distance ds, and this is r. So ds equal to r d theta, right? We know that. What is ds? Since this is v, that means ds would be equal to v times dt equal to r d theta, right? So d theta over dt equal to v by r, and this is known as angular velocity, the rate of change of angle with respect to theta. This is called omega. Okay. So v equal to minus omega r sin theta I plus omega r cos theta j. Okay. This is the equation. We take the omega r out and we have minus sin theta I plus cos theta j. Alright. This is the velocity. Okay. So we have to take out the acceleration now. So v was minus omega r sin theta I, sorry, this is plus minus sin theta I plus cos theta j, right? Now for acceleration, this is dv over dt. Okay. So we have omega r, as omega and r are constant, we again differentiate this, minus cos theta, okay, d theta by dt. Okay, yeah, that's right, minus sin theta d theta by dt j. This is correct. Okay, dv by dt, this is equal to omega r, this is again omega. Okay, so omega square r. All right, so we have minus cos theta I, sorry, this is negative sin theta j. All right, this is the acceleration a. So we see this is the acceleration when omega is constant. I have assumed omega is constant over here. Keep in mind, okay, omega is assumed constant right now. Omega square r, what was this? This is minus, right? R vector. So this means magnitude of the direction of acceleration is along radius vector. As I already told you earlier, since this is r, that means this negatively would be equal to minus r, and a equal to minus omega square r along negative radius vector. Okay. So now this was when omega is constant. I had already assumed omega is constant. Now you see r was r cos theta I plus r sin theta j. We differentiate this again. dr by dt would be equal to minus r sin theta d theta by dt plus r cos theta d theta by dt. This is j and this is I. I and j are constant unit vectors. They will not be differentiable here. We can take r out. This d theta by dt is omega. Now omega is varying. This is the second case, okay, where omega is varying now. This omega comes out, this would be minus sine theta I plus cos theta j. This was V. Okay, so actually this is positive. Sorry. This is also positive. Okay. Now, V was R omega minus sine theta I plus cos theta j. We have to differentiate this again. Now omega is varying now. First we use two function rule. First function is this, second is omega. So we first differentiate this function, okay. This would be equal to minus cos theta d theta by dt I minus sine theta d theta by dt j. We have differentiated the first function, now we differentiate omega, okay. Plus r minus sine theta, this is I, plus cos theta, this is a, then d omega by dt. Okay, acceleration r omega, this omega comes out because d theta by dt, as I already told you, is omega. So this can come out of this expression. This would be equal to minus will come out, minus r omega square cos theta I plus sine theta j. Okay. Now plus minus sine theta I plus cos theta j. Okay, r d omega by dt. Now we'll have to sort it out first. What was r? R was r into cos theta I plus sine theta j. So what is cos theta I plus sine theta j? This would be equal to r vector by modulus of r. This is known as the unit vector. The unit vector purpose is only the direction, as I told you. Okay, so r cap equal to cos theta I plus sine theta j. So a consists of minus omega square r and this term, so this is r cap, okay, plus minus sine theta I plus cos theta j r d omega by dt. Okay, so we can see here omega square r cap. This means this is the radial acceleration, okay, or we can say the centripetal acceleration directed towards negative r cap. Since positive would be outside, negative would be here, so this is AR. Okay, now what was V? V was R omega, yes, minus sine theta I plus cos theta j. Now this was V. Okay, yeah, this was V, and this is the velocity. So in this expression, the r d omega by dt, we can take r inside because it is a constant. It will always come outside. So we term r omega as V. Okay, we term r omega as V. Here omega is varying. Okay, first I want to clarify, here omega is varying, it is not constant. So what would be dv by dt? That would be equal to d by dt of omega r, and obviously r can come out because r is constant, so it would be reduced to this expression. And what is this? This is, you see, this is because this is V and we can take V over here in the denominator. So this expression minus sine theta I plus cos theta j is actually equal to V upon modulus of V. Okay, this is actually equal to the unit vector V. We have to understand this. This is actually equal to the unit vector V. So what is unit vector V? Obviously unit vector V is the unit vector which shows the direction of V. This means along the tangent, which I earlier proved. So this is unit vector V. Okay, so this means This means acceleration is composed of minus omega square r cap, okay, plus d omega r by dt, and that would be equal to v cap. So A would be equal to minus omega square r cap plus dv by dt v cap. This is the actual acceleration when velocity varies, because when velocity is constant, dv by dt will be 0 and only left term will be this, okay. But here velocity is not constant, hence the acceleration is ar and a tau, and a tau equal to dv by dt along v, because this tangent is v cap and this is r cap, okay. And this is the real solution of acceleration. If we think about it, A would be equal to r cap. This expression is v cap, okay. And obviously then A becomes root ar square plus eta square. This is the answer. This would be negative, okay. So guys, I have completed circular motion. Any doubts, please ask. If I have left anything, please tell. I will cover it also, okay. Do subscribe and read the video. Thanks.